Hi guys, now you slowly make your way back, and I'll try again.
Not a problem.
Oh. All right, everybody back. As we're really short on time, I'll basically just continue, and hopefully those interested will actually turn up. So as I was saying earlier, is a CDN based on DNS basically replies with a different IP address depending on where the request is coming from. So if you ask the same question, here's an example. If you ask the same question in New York, you actually get a different answer than if you ask that question in Boston. That's a very American example, but I mean, we're an American company. Essentially, that's really all it is. It's like you get a different answer depending on where you ask from. To actually pick which one we answer with is really, there's a lot of internal criteria. We see where we have the best latency, where we have capacity available, where we have server cycles available, and so on. So this is really the gist of how our or any other DNS-based CDN works. So you have the end user on the left here, asking his ISP's name server, where is example.com. And then you have the whole recursive DNS lookup. This is, step 2 is actually multiple steps depending on what's cached already. So it can go all the way back to root if necessary. And then comes back with the authoritative name server. That's in this case the name server of the CDN. In our case, Akamai. And that's where the magic happens. This is really the whole magic of the CDN. The name server gets the question, example.com. It looks, where does this question come from? And in this case, it comes from this name server. It does not actually know who the end user is at this point. It gets the question from the name server, and that's all it knows. This name server 1234, it looks up its internal logic and replies, okay, server from cluster 5678. It replies back to the name server, and then the name server replies to the end user. And then in a completely separate step, end user actually goes to that cluster with an HTTP request and gets the content. At no point until then do we actually know who the end user is. We only see the end user IP at the point where, okay. I clearly am not qualified for modern technology like this. So we only see the end user at this point where we actually get the HTTP request. And that is perfectly fine as long as you use a dedicated name server in your ISP. The moment this breaks down is if you use some other name server. And what's very common in this case is Google and OpenDNS. There's obviously others, but those name servers are in central locations around the world. Like the nearest Google name server to here would be in Singapore. Donald, correct me if you built some other since I wrote this presentation. So this would actually go to a name server in Singapore, and we get the request from that name server. We have no idea at that point who the end user is. So how does open name servers usually work is they have like a separate front end and back end address. Everybody knows the front end address of the Google server, plus just 4 8s. But actually that's not one address, that's any customer around the world. There's many hundred name servers behind that. And they all have unique backend addresses. So in this case, this is one in Singapore. They have addresses out of this range. So the end user goes to 8888, but you reply actually, the recursive request actually comes from the unique backend address. That's the 74 address here. So we can narrow it down somewhat geographically. We don't just know this request came from anywhere in the world. We know it comes from Singapore, but that's the extent of it. We know it comes from Singapore. We don't know which network it came from or which end user IP it came from. We really only know it came from a Google server in Singapore, which means we cannot map it to a local cluster in the ISP in Bangladesh. We can map it to a big infrastructure cluster in Singapore, where we know we can reach the whole internet. So in this case, that would be most likely Equinix in Singapore, where we have a lot of connectivity to different networks. So you would get that content from Singapore, which isn't bad, but it's obviously not great when you're in Bangladesh and you actually have a cluster locally. Now, those name servers are used very differently. So from this data we see, that's obviously not necessarily identical to what Google sees, but I think similar. In Europe, in Singapore, in the US, there's very, very little usage of those servers, so it's not a big problem. But the moment you come to developing countries, and especially countries that do some sort of DNS-based filtering, there's actually a huge uptake on those name servers. So like in Turkey, we see 22%, in Vietnam, we see almost 30%, Bangladesh is 23%, so it's like a quarter of the requests in Bangladesh actually come from one of those name servers. That's obviously a huge percentage, which means a quarter of the traffic we cannot map locally, which is not good for us as a CDN who wants the performance benefit, and it's not good for you guys who want the traffic locally. This is actually data from Bangladesh, which is quite interesting. So I excluded the names of the ISPs, but you see like the first two are fairly typical ISPs you see around the world. Most of the requests come from their own name servers and a small percentage from other stuff. Where it gets interesting is further down. So ISPC already has like 20% of the requests coming from Google. That's a significant percentage. And if you look at E, that's almost half. So that is traffic which really has a significant impact on performance. What's also very interesting to see is those are both mobile networks. And that's actually something we've seen increasing massively in developing countries in recent years. I've never actually seen it as high as here in Bangladesh. This is Opera. So this is people using an Opera browser and actually kind of proxying traffic through there. That's something not captured by this now. I'm going to concentrate on Google and OpenDNS. So what do you do to solve this problem? We need to know where the end user is to be able to map it better. There is a draft. I think this draft actually has expired by now, but we're still using it. Google uses it, OpenDNS uses it. to essentially include the end user prefix in the DNS request. So give us an additional field in the name server request telling us not only this is the name server IP, but this is the subnet it was requested from. This has to be supported by both sides, so the open resolver like Google or OpenDNS will do that, and it also has to be supported obviously by the CDN in question like ours. This is how this looks like. I'm going to skip over it. This is basically an additional field that just submits that additional information to us in the original DNS request. And that changes the whole picture you saw earlier slightly. So everything is essentially the same up to step 3. In step 3, we not only get the request from the name server, we actually get the request from the name server with an additional field telling us who the end user is. And that's all it is, really. We get this one bit of additional information, which enables us to actually make our mapping decision based on the end user address instead of the name server address. And in this case, we can see, okay, this end user address is actually in Bangladesh, so I map it to a cluster in Bangladesh instead of the infrastructure cluster in Singapore. This is really the only additional stuff that happens here, but it makes a huge difference. So there's obviously some concerns there about privacy. If we get the end user address, we could do all kinds of dodgy things with it. I think the important thing to note here is A, we will know the end user address anyways at the time you make the HTTP request to us for the actual content, so we know who we are anyways. So this is not really giving us information we don't have already. And B, it's actually kind of anonymized because we only get the /24. We don't get the last 8 bits of the IP address. So we don't actually have a specific end user address in the DNS request. We only have the first 24 bits. You can also request the name server to anonymize that by basically tagging this field with 000. That doesn't always work. So if your purpose of using a third-party DNS server is to hide your origin, don't use one of those. Because that basically won't work anymore with this protocol. Again, security-wise, there is potential for all kinds of attacks, but they can essentially be addressed with the exact same measures that are already in place to prevent those kind of attacks without the feature. So there's nothing new really introduced here that will break things. The main concern is this kind of cache pollution. Obviously, the cache name server of Google, for example, has to store a lot more information because it has to now cache an entry specific for every end user subnet, not just for one reply. But then again, Google is aware of that, OpenDNS is aware of that, their name servers are scaled to be able to handle that. But this is an issue if you try to run that at home. Again, prefix lengthwise, I was going to skip over that, I just mentioned that already, is essentially always truncated at the /24. That can cause some granularity issues if the routing table information we have is not on a /24 level, but the gist of it is it will still be a lot better than mapping it to Singapore. So this is an example where we just, to give you an idea how this changed things. This is from India. I unfortunately don't have a graph for Bangladesh, but I think it's probably more pronounced in Bangladesh because it's actually a high usage. When we switched this feature on, we saw a really sharp drop in the average distance of certain traffic because essentially before it was coming from Singapore, now it is in country. I'll skip the last part because we're already very late. Essentially, just to sum it up, this can also be used in a partners network. In Bangladesh, that's not likely to be that much of a concern, but if you look at very big, widespread countries like Australia, like the US, or Indonesia, we've been talking about it as well. It's you can use this potentially in a partners network to pick the best location within the partners network. But what we found working with those several partners is that actually the overhead of implementing that in a partners network is usually higher than just deploying a couple of additional NIC servers in those locations. So we don't generally recommend it unless a partner really wants to do that. So I'll keep it at that. If there's any questions, please feel free to ask. Otherwise, I think we're going to move on with the program because we're already like 45 minutes behind. Sure.
Hey man, just to echo your comments on Opera, right, as a browser. It's a fantastic product, Opera. And the browser does some compression, and it takes it back to somewhere else, and they send you a lighter version of the internet page back. There's some end user problems though with that approach these days that have been exacerbated. One is that for many users, Opera doesn't have extensive infrastructure, say Akamai or Google or yourselves with local service to. So it means you've got a very long path to go back to the nearest Opera location. Okay? And the second is that with an increasing number of HTTPS requests, and all of our services are migrating to HTTPS by default only, you actually can't really do the compression on those things. Okay, so Opera's ASN is still a substantial bit of our Bangladesh volume, and we egress it from Amsterdam. Right, that's not good for you guys. So I don't know if there's an easy solution, right, but it's just pointing out that some of these things is a trade-off between cost and performance that you need to bear in mind when you're picking what you want to do.
Yeah, absolutely. This is a big issue. Essentially, this whole concept of proxying it, the traffic through a remote location, and Opera's location are not in Asia, they're all in Europe or North America. So this is actually kind of halfway around the world from here. So yes, it compresses the pages. Yes, it basically gives you a lighter version, but it actually comes from halfway around the world. So I'm not sure it actually gives you a performance benefit. And it essentially breaks the whole CDN model for Google, for us, because yeah, that traffic has to be served from Europe or North America, even if the end user is in Bangladesh. So that's an increasing problem we see with mobile networks in developing countries. As I said, Bangladesh is the highest numbers of Opera users I've ever seen when looking at those statistics. For one of the mobile networks here, that was almost 3/4 of the traffic. And yeah, you have to keep in mind if your users use this Opera browser with this feature enabled, that essentially means that traffic comes from Europe in most cases.
So I think anyone has any question? No. Thank you very much. So this is the end of the first session. The second session will be conducted by Mr. Moin. We have a very good presentation from our regulator, from Grameenphone, so it's very good. So Moin, please come. I have a small question for you for regarding Opera. So let's say Opera is not your client, right? So it's not on your CDN. So if anybody has CDN from or cache from Akamai, you will not get support for Opera.
No, essentially the Opera browser works as a proxy in between. So the end user request goes to Opera, and then Opera requests this from their location in Europe, and then builds the website and sends it as a package to the browser. So for us, the request comes from Europe.
Okay, so we are reading from Europe, if anyone is browsing through their cell phone.
Yeah, something or somewhere in northern Europe, I think it's Sweden or something like that.
Hello, good morning everyone. In this session, we have a very good presentation from our regulatory commission, BTRC. Excellent Honorable Muhammad Zulfikar is going to present it on behalf of BTRC. we welcome all figures. Thank you.
Thank you, gentlemen. I guess ladies are also there. So, dear participants, the organizers, all the guests from overseas, I think still it is time to say you a very, very good morning to all of you, and then also welcome to my presentation. The presentation, as you have already heard, that it will be from the regulatory side. The presentation will basically cover the present licensing regime that we are practicing in our country, and actually the unified licensing that the other part of the globe are actually they are adopting. So I will try to actually share my ideas, and I will also expect at the end of my presentation that all of you will have a interactive session where you should also share your ideas and also educate me so that I can put those inputs while designing the licensing guideline for our country. So you can see this flash on the screen. I will try to cover these few heads during my presentations. So let me just give you some of the understanding regarding the individual and class licensing regime. Actually, what is individual and class licensing? You can see the licensing regime that is being practiced in our country for all the operators, maybe your MNOs, maybe the gateway operators, interconnection exchanges, and any other operator like HTL, IPC. So whoever is operating in our country, in our licensing regime, basically following this individual type of licensing. This particular licensing basically depends like technology defined licensing. Maybe you know that 2G, 3G licensing, the operators are actually operating like the MNOs. Standardization based licensing, like specific standard based licensing like EWA operator or something like that. And then we have also resource defined licensing. If the allocation is something like that an operator will be only allowed to actually operate in a particular spectrum band, then we can call it, or in a particular resource based, then that can be one kind of individual or class licensing model. Also, we have the network topology based licensing like the carriers, the submarine cable broadcast, the IPCs, also the gateway operators like IGW, IIG, the interconnection exchanges already I have mentioned, and some other network service providers like ISPs, IPTSP, PSTN, and also the OTTs. Now, we also have two different dimensions in licensing. One is the open licensing, and the other one is the closed licensing model. So, in the open licensing model, it remains open to all, and it does not actually mandatorily say that a particular number of licensing will be there, but it remains open. But the other way, in the closed licensing regime, the government decides, based on the feasibility, based on the market size, and how many licenses will be actually given to the operators. So in this type of licensing, little bit of advantages are there for the industry side, that the operators can actually design their rollout applications. They can plan that how much market they are going to have, and then they are a little bit certain for their investment and on their return of investment. So this is a very small picture, but it speaks about the big licenses that are prevailing in our country. You can see that over 2,000 licenses are there in different segments. Just in CMPO, 6 CMPO, 11 PSTNs, And in the entities, you can see 5 entities operator, 6 ITCs, 1 submarine cable, 29 IGW, 840 BSPs, 26 ICX, 37 IITs, and in the smaller segment, you can see that 282 licenses were given for the call centers, 14 BTS licenses are also there, and enormous number of cities are operating, training, and promoting our this industry. Now, a little bit of theory regarding licensing and how actually it prevails in the industry and also for the regulators. Now, prior to move on to that, let me just remind you actually what is licensing. This is basically a key regulatory instrument that is integral to the successful and efficient supply of telecom and ICT services. It is virtually a grant of right to operate and provide services by the regulator or by the government or case. And basically, the licensing guideline or licensing, itself actually governs some bit of restrictions as well as it has enormous scope of actually operations. Then, if you just look, why do we need licensing? As I have already said, that it gives you administrative control and it gives you the rollout obligations in which actually you have to roll out your network, your services to the general mass. It also encourages, privatization. It encourages commercialization, and it helps the regulator to regulate the market. Also, it ensures a competitive environment within the industry so that all the operators play in a level playing field so that the end users get the required or optimized level of services from them. Also, that it actually facilitates to share these care resources amongst number of operators, and also it helps gaining the government revenues, and so on, as you can see in the list. In fact, licensing gives a regime where a particular sector actually being guided, facilitated. Thereon, the industry players, the operators have a sustainable environment, smooth competition to put their investment and get their return on investment, and at the end of the day, government gets legitimate revenue from the industry, and not least, it is basically the end user, general mass gets quality of service through licensing regime, I should say. Now, actually, what we really look when we frame a license, basically, it is a balance between the efficiency and effectiveness. Actually, in this particular part of the the utilization, the telecom and ICT is playing a true vital role in every sector. So, every day, the technology is changing. So, thereon, you need some time to actually achieve the efficiency and how to actually put those technology for us, for the operators, and for the general mass in effective manner. So, we try to find out some bit of guiding principles or something or some limitations, some restrictions, some customization for our society, for our environment to actually get the true benefit from the technology. So always, whenever we actually plan to frame any licensing guideline, we look for this particular two keywords: how to actually make it efficient and to make it effective. And as you see, the key principles of effectiveness are very, commonly known to all of you. This is simplicity, flexibility, certainty of service, technology neutrality, and also equal treatment for the licensing. The efficiency involves reducing use of resources, such as cost and time in licensing process. Now, actually, just one thing that actually the approach of licensing. Now, once we have actually framework is done for a licensing review, then how actually go on to that licensing deliberation and actually award the license. And the approach of licensing based on basically is something different what is basically practiced in other part of the world. You know, in the maybe in some of the countries like Australia and New Zealand, I will just come on to that. We have different kind of license awarding situation. There is no licensing in some of the countries, but however, their industry is running very smoothly. But in our country, in our case, we have number of licenses. Still, we have some bit of problems, some bit of overlapping, some bit of dependencies between the different categories of licensing. Like if I just if I just give you an example, that entity and operators sometimes they are basically meant for laying the or deploying themselves for the infrastructure development to actually promote the services. Once MNO and other operators goes to those entity and operators to have their infrastructure, many a time we just come across different kind of problems that entity and operators are sometimes are unable, or sometimes they say that well, we'll not actually roll out our resources in this way or in this part of the the geography or in the remote spaces. They are not actually ready to deploy themselves. So that is how the dependence, like the MNO operators, the MNOs, what do they say? That they cannot actually roll out their obligations. They cannot actually fulfill their service obligations to the general mass. So that's how a little bit of dependability between the operators in different regimes that I will be coming on are there in practice in our country. Then, like any other country, licensing principle is very simple. Internationally, the licenses should be focused to the entity which can bring maximum socio-economic benefits for the country. It's a very small and very true sentence, which is applicable for our case also. But once we actually design the principle for BTRC, for our case in our country, we also look at the same kind of principle. However, BTRC actively considering to move towards the effective forward-looking licensing framework which would enable the nation to realize the full potential of telecommunication and information technology industry. In fact, this particular scheme or this particular practice of the BTRC will certainly enable the growth and support of the national aspirations, and it will turn our country to be a middle income country or a better country as far as the economic sustainability is concerned. And on the other hand, the united licensing regime, which is the key issue basically, this brings effectiveness, efficiency, technology neutrality, and convergence of the total individual class licensing. Sorry. As you can see on the screen, the universal licensing regime, basically there are a few key elements. This is, first of all, it is simplified and unified regime. It is certainty is there in licensing model, and it is consistent treatment for the all licensing holders. So as you can see, actually it is once we think of migrating from the ICLR to the ULR, I mean the class regime to the unified licensing regime, we should just remove the categories, remove the classes, and then actually we have a platform for the licenses so that they have a little bit of certainty, as I have said, that it should be clear, open. It should be a clear, open process with public consultation or the industry consultation. And then there has to be a means of administrative appeal, no open-ended discussion. So once it actually, the operators will have a sustainable framework and then they will have a little bit of peace in their mind. So they are certain about their competition, they are certain about the number of licenses in the same class, and also they are not dependable or dependent on the other resources. They can plan themselves in line with their own resources, and they can actually roll out their own network, they can roll out their own infrastructure, they can have their technology neutrality, so that, choose between the devices, and then they can give better services to the end users. Now we have a proposed transition framework. Basically, this is from the class licensing regime to unified licensing regime. The implementation of ULR requires careful planning and comprehensive assessment of a range of issues. Basically, this process will mandatorily necessitate the industry consultation. Our industry is a little bit already mature, you can say, in all the classes. So we have number of operators in different categories. So unless and until we have a consensus with those industry people, it is very difficult to actually move from the class regime to convergence or to unified licensing. So as you can see, it is first on the screen. There should be an assessment of the current licensing framework, assessment of the appropriate level of regulatory intervention, development of the process of issuing new licenses, determination of which licensing regime is more appropriate, and finally, developing a transition or migration model or a roadmap for this migration, so that it transits from the present regime to the convergence or the unified licensing regime. What is ITU recommended model? It is just a small, what should I say, a small flow diagram that, as you can see on the left, many different license and operation types, and then this needs to be consolidated. The consolidation of the licenses and different kind of authorizations that will actually categorize in broad category, not in a functional category. It will be in the broad category level, and maybe you can just see in the middle box that the two categories will be network a category and the service is the other category. And the unified licensing model, which actually we are looking for, that will be the unified licenses that actually encompasses all types of service and network together. And ITU, since a long time, basically they are provoking all of us to actually go for this type of licensing. So, what is the common practice in our case in Asia Pacific? You can see on the screen that the trend, the separate licensing, the separate licenses are there, and at the end there's the convergence. And in between, the digitization of content, developments of devices, and also the broadband internet access. This all actually goes into a convergence. And in the second row, as you can see, the ITU proposed transition model that I have already delivered, or I have already shown it to you. The same thing. And the common practice for transition in Asia, if we just look into, you can see that this particular sorry for the interruption. So as you can see on this particular, the screen, the common practices that is the initial assessment. The initial assessment is to be done. Then we'll have to just look into the new license structure from the present regime. And for many other countries, like our cases also, we need the parliamentary or the governmental approval for the licensing regime. And finally, the adoption of the, the licensing regime that we are looking for, or we are just trying to say. So this actually give you from the separate or the class licensing framework to the convergence model, or ultimately to the unified licensing regime. Now the international best practices. is the same thing that I have been telling you, that rights and obligations of licensee should be clear and consistent, and with changes resulting only from the transparent consultation. Licensees should have resources to independent and transparent dispute resolution, or there should be, I have seen different kinds of problems coming up. Regulators should move towards a unified licensing framework by consolidation the small and the class licenses. The licensing framework should be consist both individual licenses for public telecommunication providers and class licenses for non-public services with limited scope. Licensing framework should meet the regulatory requirement of a converged telecommunication sector. Licensing should be technology neutral. And finally, where there is insufficient competition in the market, licensing should be used as a means to actually facilitate the competition, including new market entries. Now, if we just look into some of the cases of Asia Pacific, how they have actually moving, or some of them have already moved towards the convergence. We just look into the case of Australia, the Telecom Act 1997, they have already regulated the carriers and service providers. And the carriers, basically the sort of infrastructure and all these, and the service providers are the end users. I mean the service providers, the ANS, the access network service providers in many forms. In Hong Kong, they have introduced the unified licensing in August 2008, which authorizes the provision of any combination of fixed, mobile, and converged services. And in India, they have also introduced, not in full scale, but however, they have introduced this unified licensing regime in 2003. They have also implemented this transition in two phases. The first phase, the basic and cellular services were transitioned to the unified license, and the second phase, which commenced in basically 2005 and involved full transition of all services to the unified licensing regime and ended service-based licensing. In Malaysia has two broad types, as I have said, in like many other countries. This is the network facilities, the ownership of the network facilities, and the other one is the network services. In New Zealand, actually there is no licensing, and interestingly, in New Zealand, I don't know anybody is here. Oh yeah, I have made somebody called Mr. Ganda, probably he's from Commerce Ministry. I found him in, maybe I may be wrong. I found him in Sydney in last regulators roundtable, and he was telling this very nice story of New Zealand. They do not have any licensing. I don't know. Okay.
That's correct.
Yeah. Thank you.
There's no licensing, but also in Australia, I don't think you need a license to be an ISP.
Yes. This is there.
There's regulations, yes, but you don't need to apply for a license.
Yeah, thank you very much. So the thing that I have been telling, in New Zealand, there is no licensing. But however, the government is there to regulate, of course. And interestingly, the regulations, the telecom or the ICT regulations is done by Commerce Ministry. It's not the, I'm not sure they have a telecom ministry or not, like our country or many other countries of the world. Okay, so in Singapore, they have also two classes of licenses, namely the facility-based operator and the service-based operator, just like many other countries. Also in Thailand, they introduced the current licensing system in 2001. This includes three licensing categories. One is the licenses for the operators who do not own their own network, I mean the network infrastructure, and type 2, they may have their own network infrastructure, may not have their own network infrastructure, but they are destined to actually go for a very limited scale of operations, like our local ISP, just ISP licenses which is being given for the zonal operation, something like that. So they don't actually operate in total country. And the number 3, or the type 3 licenses for operators with their own network infrastructure who provide services to the general public in broader framework to cover the total, the nationwide, I can say. So it's a case study of Myanmar. Just you can see network facility services. The authorization actually it gives the authorization for construct, maintain, and operate network facilities. And accordingly, the activities you can see in the down, the same column in the later row. And they have the network facility services like NFS. They have network services. They have application services. So different kind of the licenses are there, and we have the authorizations and the activities accordingly. Now the case of Bangladesh. Actually, how can we actually move, onto the convergence that we are really looking for?
Colonel,
Yeah.
could I just ask a quick question on your last slide? It was a very detailed case that you've gone through of Myanmar. I just wondered why you chose Myanmar, because it's not really recognized internationally as a shining example of good telco regulation.
Well, it's a very good question. Thank you very much. Once we practice some understanding for any particular subject or any particular technology, we try to actually look into our neighboring countries. So that matches the most of the part to be adopted or maybe to be actually migrated for our cases. So you were correct that Myanmar is not internationally recognized as far as the telecom and the ICT cases are there. However, we found this particular case study a little bit adaptable to our cases, because if you can just track back the very second slide of my presentation, you saw that the number of licenses we have, almost it is more than 2,000 approximately. So in different category, even this is the number is too high. So to merge them and to box them in a single category of the single classes and then go towards the convergence, I think few transitions we need, and these transitions are being there in the Myanmar policy. That's why the case study actually we have focused on their case study. We have different case studies as well, but for the audience today, I have just scattered for this one. Thank you. So let's come back to the convergences. We may have two different kinds of convergences for Bangladesh case. That we can go for a vertical convergence. And later on, I will show the horizontal convergence. As you can see that in this particular box, just try to follow this one. The infrastructure company, the NTTN, and the ANS. This is what is the actually vertically dependent to each other. And in the other side, we have the interconnection exchanges, the gateways. And this is the final gateway to go towards the outside world. This is the ITC and the submarine. So what we can do is that we just like to collapse these particular classes vertically. Just these three can be put together to make the infrastructure core. So infrastructure core actually will be the NTTN and the ANS can be vertically converged. And the other side also, you can see the ITC, the IIG, the gateways, and the IW and IIG, and the exchanges, and the interconnection exchanges like ICX and the NICs. These all can be converted to one side so that it can, the ICX, NICs, IGW, and all licenses can be vertically converged together. This particular vertical convergence actually from Bangladesh context, the access network and the transmission and services gateway. This will define in this manner, and then actually we can play ourselves between these two or three classes of licenses. And if you just look into the horizontal convergences, this is also possible for our case, like the CMPO, the PSTN, ISP, and the BWA. This is the group. These are the ANS operators. Then you can see the interconnection exchanges, the ICX and NICs. Then the gateways, IGW and IIGs, and finally these are the ITC and the submarine cable. So we can put also these the ANS operators together, these international exchanges together, these gateways together, and finally the ITC and the submarine cable together. And we can have a sort of convergence from many different kinds to some bit of prescribed 3 or 4 kinds of operators. So it is basically the other one, the convergences vertically and horizontally together, and then make a hybrid convergence model. This actually I just like to propose in a way. Maybe it can be adopted in our telecom policy. It can be adopted for the industry maybe years to come. So you can see on the screen this similar type is network facilities provider licensing, then network service provider licensing, and then application service provider licensing, and finally the content application or the service provider licensing. So two makes virtually the network related. One is network facility provider and the network service provider, and the other two actually mostly on the application based, on the application service providers. Anyone please help me? Yeah, Mike.
I'm enjoying your talk. Just another question. On the content application license side, I see there's some number of sub-bullet points. Is the intention with this idea that, say somebody in Bangladesh wanted to create a blog, that they would have to get a license to create a blog? Because that's content, right?
So, if I could rightly got your point, that is, basically this particular content actually we want to facilitate, as you have said, that this proposal for our condition, our context. So we have a number of content providers in the country. So the content providers, they are not under our regulations. Since they do not have any licensing regime, or we do not actually give them any sort of NOC or any type of license. So since we cannot actually regulate them, what do? They are doing their operations very nicely, but once they actually go for their business with the the operators like MNOs, the IPTSPs, they do not get a right kind of the profit sharing mechanism, and they cannot come to us as well, but to the regulators. Reason is that they are not licensed. So we just cannot actually listen to their problems. So that is the reason that we like to put all these content providers, those who are working just like the small cottages in our country, thousands of people are there, thousands of people are actually designing contents. They are actually, trying to actually promote their contents to the service providers network. We want to facilitate them, but essentially this does not mean that somebody is doing the blog and we will actually try to regulate them. We are not trying to regulate them, but as I've said in the very first few slides, that the licensing regime is to facilitate everything. It is not only to regulate, it is not only to gain the government revenue from them, and it is also to facilitate their competition. It is also to facilitate their sustainability, economic sustainability, growth sustainability, and all these things. So this regime is not to actually discourage the blogs or the blog content provider. They will be operating definitely within the purview of the legitimate constitutional obligations, of course, for this particular country. I guess, could I just answer you, sir? Oh, thank you. So the recommendations look like this. Then the ILDC, gateway operators, infrastructure, exchanges, access network, and end users. You can see the different kind of delivery they do, and the types of operators as well. So it is already number of times we have said. The converse scenario, the ILDC operators, they will be dealing with the raw bandwidth, and infrastructure operator, they will be the X gateway, X infrastructure, along with the LI prop and monitoring platform for both the routing, international and domestic routing. And the operators, the access network operator, they will be dealing with the voice, data, and definitely together as well. And end user, virtually end user with us will have a single connectivity for word filling and the cellular mobile services as are expected. The regulatory arrangement should be something like that. We need to actually amend the policy, the ILTS policy that is existing for our case. So for ILTC operator, if you just go for a converged model, then we need to actually review that policy. The licensing also need to be reviewed. The ITC, submarine cable, IGW, IITN, those will be actually merged together in different classes. The infrastructure operator, ANS operator, accordingly, the policy, the main thing is that the policy needs to be reviewed. Accordingly, the licensing guideline needs to be reviewed, and licensing or the license itself needs to be, renovated or revamped, you can say. So, implementation roadmap, it is just a proposal. It is a wild case. I don't know whether it suits our, but we can have few years to actually go from this particular present regime of class licensing to the conversion of the ULR. So maybe it will be 6-7 years. The last line, as you can see. I don't know. The government should start now. That's what I can say. And last slide is basically the last slide from my presentation. Now, I just like to share one more thing to this house. Just unified licensing regime. Just visualize something that you have a laptop in front of you, and you have the resources in front of you. You just have a software. You have a software, something like that, to get the licenses. So in the software, the first category comes, do you need a spectrum? So you say, yes, I need a spectrum. So then it will ask you in which band. So you give the band, how many, the bandwidth. So you give 10 megahertz or 20 megahertz or something like that. So that goes. Then it will ask you, do you want to actually go for infrastructure laying, or you want to deploy cable? You say, yes, I want to deploy cable in the whole country or a specific region of the country. So you say, I'll deploy my cable in a specific region of the country, maybe in the hill tracts, maybe in the northern part, maybe in the southern part. So you keep on checking different options that come, and at the end, it asks you that which technology you want to operate. 3G, 4G, LTE, or something like that. You check according to your wish, and then have a total parameter of licensing space, right from the infrastructure down below the access network. And you have a unified model. So you have a unified model. So you don't actually depend on the other operators for your network, the rollout obligations for your business case. You have your own understanding. So you lay your cable, you deploy your fiber, you go to certain space, you do the business, you provide the technology to the people opt for it, the people goes on to your particular services. And accordingly, you have your own sustainability. You don't need to actually depend on anybody, any other. So if you have this type of licensing regime, that is really called the unified licensing regime. So I don't know whether it is applicable for our case or not. So many categories of licenses, whether it is possible to convert all them together and then go for this type of understanding. So the question is that, do Bangladesh really need any transition towards ULR or not? There's the question to the industry, that they want to actually play independently, or they want to play the way they are playing now. And that particular ULR should facilitate, the technology neutrality. Network topology will not be there. They will have their own network topology, and they will have their total flexibility to operate in the market. And if we need that, do we really need convergence prior to that? Because as I already said, too many classes, too many categories, too many licenses. So making a transition through the convergence to the ULR, that makes a little bit, maybe a traumatic. They may not agree, and at the end of the day, the total issue may be tightened. So, do we really need any convergence prior to ULR or not? And finally, I just like to say one thing. That is, other than my the overseas guests here, I am sure that you must be knowing that I am a very new face in this kind of presentation, and I don't know how far I could actually make people understand and give you the glimpse of the convergence of licenses or the unified licensing regime and actually what we have. So I'm sure that at least you could gain some bit of understanding through my presentation. And if it is so, then I will be very happy. And we have a sort of interactive session. I will encourage everyone, or I request everyone actually to have anything. I'll try to actually clarify. If not, we'll clarify laterally. So somebody will raise some questions and somebody else will answer. And last but not the least, thank you very much for your patience hearing. Let us go on to the interactive session. Thank you.
Sir, I have a small question.
Yeah, please.
Indian Telecom Regulatory Board have taken initiative for radiation activity law, the follow ICNLP guideline, and most of the Telecom Regulatory Board to follow such kind of guidelines, ICNLP norms. So, do you have any near future have any plan to work on ICNLP guideline? Because radiation is in terms of health as well.
Thank you very much. I got your point. Right at this moment, there is no such specific case that we are really taking up as to actually look into for encountering this radiation hazard or the public health hazard issues. But we are doing it in a different way. We are trying to actually make a sort of, tower companies. We are trying to bring a new regime that you can call it a tower company of the infrastructure, the tower company only. So that the MNOs, the BW operator, they are not allowed to make, in a haphazard manner, they are not allowed to make the towers and the thereby, keep themselves as a source of a lot of radiation. So we are trying to actually have a control over that. There will be tower companies, maybe 1, 2, so they will regulate all these towers. They will manage all these towers. They will install all the towers for all the operators. So the MNOs will not haphazardly able to make towers the way. I can just share one statistic with you. Presently, we have around 27,000 towers, say to 27,000. Whereas for the total network coverage in our country, the 15 to 16,000 towers is sufficient. So that is how we are going to actually reduce the number of towers, reduce the number of electricity consumption, reduce the number of other way the radiations, as we can say like this.
Hi, my name is Navidha. I work with Internet Society. In my previous life, I was working with the regulator, so I'd just like to ask an interesting question in terms of the sub-regional things that is happening with regards to OTT. So we just saw that the Indian telecom regulator came up with a consultation paper on OTT, which was not much appreciated within the civil society organizations, very particularly the end users. In Pakistan as well, we are probably having a telecom policy review where the policy makers are thinking to introduce an OTT licensing regime. So I just wanted to throw this question to you with regards to Bangladesh as well, because it's a huge population and the growth of internet is substantial, and we all know this OTT is such a fancy tool of applications being used by the user. So is there anything in mind of the Bangladesh telecom regulator with respect to OTT in future?
Well, thank you very much. Regarding OTT, actually, we are not thinking in a manner that affects by the civil society or it affects the civil society. OTTs are here also. They are very open to actually operate. As you're saying that the internet penetration here is, growing very rapidly. So there will be a number of OTT players will be operating over the network, over the internet. But we are not basically, as far as I am concerned, we are not actually focusing on that in a separate way. But for our case, there are a few problems you need to admit. These are maybe some of the cases that some propaganda, something is going on through different kinds of, the social media and all these things. Apart from those issues, and I don't think that the people we are thinking the OTTs in a separate way or to control them or to do something different than what we are actually practicing right now.
I am from bank. We are using IP telephone service for our bank. So, what are the licensing issues to use IP telephone service, and what we can do and what we cannot do actually for IP telephone service?
Okay. You are getting the services from IPTSP, the IP telephone services.
IP telephone service for our home.
Oh, you are trying to have the IPTSP for your own.
Yes.
So banks, I don't know if I could recollect in a very nice way or correctly. The IPTSP licensees must have a background knowledge of handling an ISP. So it is basically for the ISP and the type of the ISP operators. But bank can have IPTSP licenses. Well, I need to check it. I don't know. If you have any such links, you can share.
Only ISP service, ISP holders are able to give IPTSP.
Exactly, that I have already said. But for the banks, I'm not sure that you are going to.
So, bank cannot use IP telephone service for his own purpose, like branch to place or branch to branch.
Okay, you can use that, but that IPTSP and the telephony service should be provided by an operator, by a licensee operator, not by you yourself. You cannot install and you cannot actually operate the IP telephony for your banks and branches. And there are many IPTSP operators. I'm sure if you just give a tender today, then people will just love to talk to you.
Thank you. Thank you.
Hello, I'm from Traffic Phone. So sometimes we see that BDNOG3 open public opinion for cyber issues. For example, a few months ago, we saw that for mobile number portability, BDNOG3 asked for open public opinion. So how effective that becomes for decision making? Because what will be in our country, people possibly alert us about certain issues, then they can keep the effective opinion. So when you are making certain decisions, how much influence that the public opinion actually getting?
Okay. Before adopting any such new thing in the regulatory regime, we have a practice. Basically, we draft a policy guideline or we draft an idea, we float it for the public consultation or the sector consultation, the industry consultation. So definitely, I'm sure that if you have given your comments, this has been taken into consideration right. And if the BTRC has not taken any of your opinion or any of your views, that is also being justified, that this particular opinion is not being catered, but this is the justification. I'm sure that it helps, and I will request all of you, whenever BTRC looks for any such kind of suggestions, such kind of consultations, please help us, give your input. We truly go between the lines to actually get some of the the hints from the suggestions that you provide to us for formulating any kind of guideline or any kind of new license or whatever you call it. Thank you. Okay, so thank you very much once again. Thank you, ladies and gentlemen, for your patience here. Thank you.
newly proposed mobile licensing framework. A couple of years ago, we were awarded 3 licenses to some of the telecom providers. Then we turned into 40 licenses. Some of the Wi-Fi providers are saying that they have 40 licenses, but the next generation technology is the 5G. And we have a wonderful presentation by Mr. Faisal Mubarak from Jamifun, who is going to present something on 5G. So please welcome Mr. Faisal Mubarak.
Okay, hello everyone. Can you hear me from the backside? My voice is a little bit down due to cold, so if you can hear from the backside, just raise your hand, I will repeat. So the topics today I am going to present is Road to 5G, why we are heading for MVP evolution. So it's actually not that advanced topic, and some people will not find that this is too much technical. This kind of business and strategy presentation. So some steps first, very first. This is the epic internet use ratio. So Bangladesh only has only 26% of penetration right now. So that is pretty much low. And compared to other countries, maybe you can find India is lower than us. That's because of the greater population of India. So another stat is mobile users, 77%. So it's good. 77% coverage is there. That means we are covering more people for voice call rather than data right now in Bangladesh. But data growth is also increasing. And this is the sad part.
So one question.
Yes, yes.
This 77%, is this based on sold SIM card or active subscriber?
No, actually the source SIM card. Because active subscriber, no operator is interested to define the active subs. Everyone will show the higher number. So this is the sold SIM card actually. So next slide, you will see mobile broadband use. That means 3G and 4G. These two technologies we are covering only 5%. So that's a very sad part of my interest slide. So we need to boost up another 95% more coverage for this mobile broadband use. So these are some other numbers. So you can see 121 million SIM has been sold from all the telcos, which can be used for mobile broadband. And active internet users are around 40 million. Last year it was around 36 million. So growth is there. Interestingly, social media users are pretty much high. 8% to 10%, penetration is 8%. So people, if they don't want to use internet, they would rather go for Facebook or some stuff. So that is another cause that can increase your internet population in Bangladesh. So these are all stuffs from March 2015, pretty much recent figures. And this is another direction where we are going. That is economic point of view. You can see network readiness index. Bangladesh got advanced 10 steps from the last year. Last year we were 119th position. This year 109 position. So at least something is going good. Maybe affordability. Some pillars are there. So I will not go very details of these slides because these are all stats. Just to reminding you that we are going forward and backward. So that's why I put those figures. So today's topic is 5G. So are you aware of 5G? How many of you are aware of 5G? Raise your hand. Only one. No one else. That means we see the topics. So I can say anything, no one will differ. So see, almost 7 billion connection already established in the Earth. That is more than the population of entire Earth. That means people are using more connection than the number of the people themselves. And evolution is going everywhere. Like nowadays, we don't want to use only internet for our mobiles. We want our car to be connected with the net. We want our staffs, meters, sensors, all are connected to the internet health devices. Some days ago, people are started using Bangladesh the health trackers. So these all are connected to the internet, and for that you need some good technologies. And just take a look at the evolution state. So almost in every 10 years, mobile technology has going fast. So you see there 1G, 2G, 3G, 4G, almost in every 10 years there is a jump. So the good part for Bangladesh is we are not that much in a part of the development thing, but whenever the technology is ready, we can get the technology at the very that level. So that's the lead time for Bangladesh. So the basic thing was 3G is good enough for mobile broadband, but who cares only for broadband nowadays? Now we want to use everything connected to the net. So faster and better mobile broadband is needed. 2 years or 3 years back, 1 Mbps or 2 Mbps speed is good enough. I can still remind in my early days, 4 to 6 Mbps in a dial-up connection, and I'm happy. But right now, no. In my home, I use 10 Mbps fast, still I am not happy. So I want faster and faster thing. So that can be only delivered in Bangladesh through MBB. Also the wireline is there, but through MBB is very fast. So again, some other numbers. More than 8 billion smartphones right now in the market, and all the figures are not directly related to Bangladesh. It's a global perspective view also. So this is another picture of the evolution, 30 years of evolution. So every time mobile technology evolves to somewhere, every time it is not evolved, sometimes it is also disrupted as well. Like wireless technology in Bangladesh, so it starts with a boom but fails. So we are now thinking about the LTE, and maybe in future we will think about the 5G as well. So some may ask, we did not even deploy LTE. So what's the need of 5G? 4G is not enough for us. So you see there, 4G will actually coexist with the 5G. So it's not that when we will start for 5G planning or deploying, 4G will be gone. That will be not the case. At least up to 2030, we can have a roadmap that LTE and 5G will be coexist altogether, serving different kind of needs. So when we need low latency, like nowadays, if you deploy LTE handset or something in your home, you can get around 50 millisecond latency. But when you need some real-time action detection, like some sensor or some meters need to be synced in real time, those 50 milliseconds is a big thing. So you need a tactile internet, like 531 millisecond connectivity. So that cannot be achieved in LTE. So that's why we are thinking about the 5G in some upper spectrum as well, like millimeter wave. And WLAN is always there. So those people who are loving Wi-Fi, so it will be there always. So what's the driving force? That means why should we go for 5G? It's obviously costly to adopt a new technology for everyone, not only for the service provider, also for the end user customer. So now, right now, I know I was earlier in a LT company. The main challenge to enter in the market is market readiness. Customer is not ready. So we can offer, okay, LT is on from the 1st of June, but customer need to buy high price CP or their handset need to be capable of 4G. So now again, we offer, we will go for 5G in 2017. What will be the percentage of customer that will be welcoming this technology? I think less than 1%, only the tech savvy people. So driving force need to be very clearly identified. So it's a massive, providing massive traffic capacity. I will short the slide because time is very low here. Mission critical data, texting densities, non-traditional devices like short packets. So not going to be very much detail, only the key slides. So technology is developing exponentially, but human intuition is linear. That means some days ago we are thinking about, okay, we will need around 10 terabyte of data volume for a day in telco. Right now that is going past 100 terabyte. So eventually it will go past 1000 terabyte. So that need to be adopted by some newer technology that is 5G. So that's the evolution. This is a vendor slide actually from Ericsson. This slide is from Ericsson, and also the every slide source is mentioned. So they are saying towers 2020 we need at least 5 times lower latency, at least 1000 times more mobile data volume, at least 10 times more end user data rates, and also 10 times battery life. So this will be the 5G vision. It will be a hyper. That means not only our phones are connected. This will not only the net device. Everything need to be connected. So you see a small. What's the point? Okay. You see a small bubble is there. That is only the 4G. So everything else surrounding the bubble, that is vehicle, smart sensors, emergency, high-tech equipments, social cleaning, augmented reality, virtual reality, it need to be covered in 5G. So this is a case study. Like Dhaka is sometimes a blessed city because we have more than 20 million subscribers here if we want to deliver. So nowadays, all the service providers are providing flat rate, right? You go in Mirpur or in Dhaka, Uttara or airport, everywhere you will get the same capacity, at least in Dhaka. But things are not same always. When we are in traffic jam, we need more connectivity because people are sitting idle in the car. So they decide, okay, let's enter some movie in the YouTube. When we go to stadium for watching any cricket match, like India Bangladesh match is coming, so we then want to take some selfies and upload in the Facebook. So every scenario, the traffic requirement is not the same. So there are 7 cases. This is developed by 5G PPP forum, and basically the calculation are based for Bangkok. So Bangkok and Dhaka is almost similar kind of population. You see shopping mall, open air festival, virtual reality office, traffic jam, stadium, every scenario need different treatment. So if we prescribe same medicine for every patient, that will not going to happen that satisfy the customer. So whenever we want to go for shopping, we need to find some way looking which shops are offering discounts. So if your connectivity is not that much, your coverage is not that much, you cannot provide. So these all sectors need to be calculated, planned, and deployed. So let's take a look at the data pattern. You see the violet portion, these are videos. So again, this is also a vendor slide. So Ericsson and Alcatel-Lucent, they predicted that around 2020, 50% of the traffic will be video. So video. So nowadays also we are seeing the same. Whenever we fail to do something, we start it on YouTube. How to do it? How to type. So this is a very common case now. So to cater the video need, because video is a high volume data. So when you send email, it's easy to send through a regular mobile, maybe Symphony or some other stuff. But when you want to get some good visibility of like Google Hangout video from today's session in YouTube in 1080p, you need very good handy internet connectivity in your smartphones. So for that, these all are predictions. What is the requirement in the core and access network for that? I will not go very much detail for technical stuff. That will take more day long. So I think in the morning session, someone covered SDN and NFV stuff. So these are the requirement for 4G and 5G as well to deploy in the core, and also the IPv6, CRAN, orchestration, utility management. So these stuff need to be incorporated in telco, ISPs, whoever wanted to offer 5G. So that we can support Internet of Things, we can support big data analysis, So, whenever I subscribe for bdNOG or something, even my LinkedIn shows this announcement, this announcement, this announcement. How they know I am interested in bdNOG? Because these are all big data analysis. So this need to be more catered in 4G and 5G as well. So this is a snap of code. You see almost all the code equipment are virtualized, like PGW, LCW, MME, diameter controller, OCS, PCRF, almost all are in virtual box. So that means nowadays we are offering centralized code for 3G or for 4G, but for 5G it must be used as virtualization, so that this can be used as a pool. You can say distributed code. So how fast 5G will be? How fast 5G will be? We need some analogies. Like I'm saying 5G is fast. That's not good enough to satisfy you. You need some analogy. Like for 800 MB size movie, HD movie, if you need to download through a GPRS, it will take 36 hours. Through Edge, it will take 7 hours. So now we are using 3G. It will also take around 4 hours. If your connection is good, location is good, signal level is good, and your phone doesn't die out of battery. But in 4G, you can download the 800 MB size movie in only 43 seconds, and in 5G it's in only 1 second. That means you click on download for a movie of 1 GB size, and you just ask download it or not. So just download it. So this is the speed we require in 5G. Again, these are some KLP stuffs from GSM intelligence. So anyone can get these data by subscribing to the GSM intelligence. So this is the area where LTE is moving throughout the world. Again, I'm saying 4G will not obsolete at least till 2030. So LTE, 4G, 5G, all the technology need to be parallelly accessed, parallelly offered, and parallelly subscribed. So you see, 64% population will be covered by 4G, that is LTE, around the globe, and most of them are mainly Asia. So what's the reason behind that? Because Asia has more population. So we are bandwidth hungry people. We are interested to buy more bandwidth at any cost. So again, for that the development is going on. Mainly the vendors are driving the development. Samsung, NSN, Alcatel, Huawei, Ericsson. These are the major vendors. They are trying to develop the standards. So for that 5G PPP standard is there, and it will take long time actually for 4G to 5G things. So nothing will going to happen just tomorrow. But we need to start. We need to start planning. We need to start analyzing. We need to start ground working. So this is a summary actually for all the things. What will be the constraint for 5G? It must be cost efficient. It must be spectrum efficient because we have limited spectrum. It must be energy efficient. In Bangladesh, energy is very limited. So adaptability and security should be there. When you are all connected into internet, everyone can trace you, and everyone can trace you every bit. Like your mobile is lost, you can trace it. Your pen is lost, you can trace it. Even if you lost, your wife can trace it. So the security is breached somehow actually in social life. Okay, the objective need to be there. We have to. I have already said 1,000 times traffic, data is at the state is density need to be covered 10 times. What will be the technologies? There are a lot of parallel technologies need to cover for 5G. These are not only core network. Your transmission network, your access network need to be synced as well. So whoever is familiar with LTE and 3G stuff, you know, Wi-Fi, massive MIMO, wireless radio, SDN, carrier aggregation. Carrier aggregation is a very important thing for us because we have very small spectrum range for all of the operators, so we can do some carrier aggregation there. Small cells is also there. Now the service. which service we will offer through 5G. You see, internet is actually not there. So there are lots of other stuff. Regular internet is a different thing. It must be there. Other than that, remote medicine, smartphone, real 3D, social gaming, Internet of Things, big data, robots, all the stuff. So actually, these slides summarize why we need 5G. Again, it is not the tomorrow thing, but we need to start. So it's a long reach to be built. Let's start now. Thank you. Sorry, any question? Yes. John, you can take me.
Thank you. In the last presentation, your regulator, bdNOG3, said that there are 27,000 cell towers and wants to reduce the amount of cell towers down to 16,000. But for 4G and 5G, you'll need to build lots more cell towers in order to make the service work. What are you going to do?
Okay, very easy question for me. As I'm from the operator. Okay. So in Bangladesh, actually, we don't want to talk. We get silent. We work very introvertly, and when any regulator propose something, show some directive, we follow that. Okay, so that's the first line. BGRC will provide a guideline. You cannot deploy this, you can deploy that. We'll provide that guideline, whatever the feasibility of that. So that's the actual scenario. But to be precise, we are keeping eyes on some similar country in the world, which are look like Bangladesh, like Thailand, like Malaysia. So they have almost similar population, similar scenario, similar city density. So we are closely monitoring them, what they are doing, and we follow them. But yes, the point is very valid. Almost 27,000 BTC there. For 4G and for 5G, we need to deploy more sites, if we are not getting ROAS spectrum band. So if we are getting 700, 800, it's easy for us. We can deploy less stuff. But again, in 5G, you see, there are also a portion where we need to deploy 5G in upper band as well. So that will require a lot of sense. Yes. So I am not sure what we are going to do there. But maybe our super team there. Any more questions, please? Okay, thank you.
Thank you, Dr. Moore, for his beautiful presentation on 5G. Every day we are configuring PGP, configuring OSPF, and so many things, taking things, but we never know that actually who is behind all that standardization of this technology. Actually, it's IETA, for Internet Engineering Task Force. So here is Chris Gunnarsson, who is going to provide us a good presentation on how we can get involved in ITF and that sort of thing. Please welcome Chris Gunnarsson.
Oh, good morning, thank you. So my name is Chris Gunnarsson. I work for the Internet Society, and I'm going to talk a little bit about what's going on with the IETF, what the IETF is, and what you might be interested there. So the first thing I want to say is that no one really speaks on behalf of the IETF. So I'm speaking about the IETF, not for the IETF. If I make mistakes here or say something that isn't right, it's definitely my fault and not that fault of the IETF's. There's actually even a little web page that explains those things. And you'll understand a little bit more as I dig into this. As I said, I'm going to start with what the IETF is, then look a little bit more personally at why the IETF might be important to you specifically. And then once you realize that it's important, maybe we'll look at what the IETF is working on and then how to get involved, if those things sound interesting. So to start with, what is the IETF? First of all, can I get a raise of hands of anyone who has heard of the IETF, knows what the IETF is? Okay, a few, not bad. All right, well, good. Then hopefully this will be very helpful. The mission of the IETF is to make the internet work better by producing high quality, relevant technical documents that influence the way people design, use, and manage the internet. So what that means in shorthand is that the IETF is the body that comes up with internet standards and internet best practices. So as you mentioned, IP itself, right? IP, TCP, UDP, DNS, OSPF, SIP, many more. Most of the protocols you think of as internet technologies were developed within the IETF and then published by the IETF. More than just standards and protocols, though, more than just documents, it's really a global community of internet engineers that come together and work out these problems. It's an international community. It's open to anyone, so all of you are welcome to come participate in the IETF. As a network engineer, you probably have something to share. There's also people from vendors, people from universities, and all over the world. The ethos of the IETF is that everyone may participate. They try to keep the participation threshold low, which means making it easy to participate. All the work is freely available. As you may know, there's RFCs, right, the Request for Comments document series, which is out there on the web at ietf.org. You can look up all the documents the IETF has ever worked on, including the ones that were published and also the ones that didn't make it to being published, all freely available and free to use. All the contributions to the IETF are judged exclusively on technical merit, meaning good ideas are used and bad ideas are thrown out. And it doesn't really matter who you are. There's much more emphasis put on the ideas themselves than on the company or individual or organization where they come from. And then, of course, the protocols themselves succeed or fail based on whether or not you deploy them. If network operators, ISPs, and content providers use the technologies, then they become the ones we hear of, like OSPF and DNS. If we don't, then they aren't necessarily heard of. And there's many protocols that come out of the IETF that aren't very widely used, you probably have never heard of. They work on rough consensus and running code. That's kind of really the heart of the ethos of the IETF, rough consensus and running code. What does that mean? Rough consensus is really about people agreeing that things are good ideas, right? It happens through working group discussions. So all the work in the IETF is broken up into individual groups of people who work on these ideas, and they have discussions and sometimes yell at each other, and then work out the best way to do things for everyone. And then that's what gets into the document. They use a practice called humming, which I think is very interesting. It's something very foreign to everybody in an IETF meeting. In the IETF, when they have meetings, in the working group session, when they're trying to make decisions on ideas that are contentious, things that are hard to decide on, and instead of voting or raising hands or things like that, they actually hum. And so everyone hums, and they kind of judge which hum is louder, for yes or for no. And the reason they do that is because the IETF works on individual contributions. So if your boss is in the room and you vote against him, you may not want him to know that. So the humming kind of makes it anonymous, but still gives a sense of what everyone thinks. And then last call is a process where these documents are sent out. There's several last calls. Usually there's a working group last call, so that everyone in the working group has a chance to say, oh, wait a minute, that's a bad idea, we don't want to do that. And then there's an IETF last call, which is broadly published to everyone who's working in the IETF. So the folks who look at different technologies can look at these and say, okay, that's good or a bad idea. So that's what we judge rough consensus, right? And again, it's really that merit-based, right? Are these good ideas or not? Running code means having working implementations, right? So when you come up with a new protocol and try to bring it to the IETF, it's going to be taken a lot more seriously if you've been able to make it work, right? So you're going to work it up in the lab, you've written the code itself, that will be used to judge the merits of the protocol or of the IETF standard. Also, just the last IETF, they had a hackathon where they actually were working on building implementations of IETF protocols, which helps to build multiple implementations, which of course makes the whole thing more robust. They've also done code sprints, which are a little bit different. It's still actively working on code at the IETF, but it's more for the IETF tools than the protocols that the IETF produces. And there's a session at all IETFs called Bits and Bytes, where vendors and service providers can come demonstrate their implementations of these protocols. So they can come kind of show off what they've built with IETF protocols. So that's all kind of the pieces of running code that goes with that rough consensus. It's really two sides of the same coin to be able to produce internet standards. The net effect of rough consensus and running code is what we like to call permissionless innovation. You don't have to ask anyone permission to deploy a new application, a new website. HTTP, right, and the whole web itself, so what we think of as the internet a lot of times is actually just the web, right? HTTP, websites, and that process. That's something that was developed completely outside of the IETF process and then brought in. Because people just started putting up websites and hyperlinks, and it happened from there. And all the other things. So companies like Dropbox, or Amazon, or Tor, or Google, or Facebook were able to build their websites and become very popular without asking anyone's permission. There's no, you don't have to get a license to work on the internet. You don't have to check in with any regulatory body. It's really just open and free to play around and build applications and then try new things. So that's kind of what the IETF is. And now I want to talk a little bit more about why it's important. And I think this comes through a little bit from what I've already said. The IETF is the principal body engaged in the development of new internet standard specifications. Right? So this is where these standards happen. And if you're meant to deploy these standards, then perhaps you should have a hand in designing them as well to make sure that you can actually deploy them. There's a lot of things included in the mission. I'm going to skip over some of this, but really it's all about taking information from the real world, from academic research, and from vendors who are developing things, putting that all together to create these standards. So really what I'm saying is the IETF is where the future of the internet is being written, and you're invited to help, right? I'd like to encourage you to help. Specifically, you, network engineers from Bangladesh, places around the world that are still developing are where the internet is growing the fastest, and where the most innovation is going to happen and is already happening. Places like the United States and Europe, where they've got kind of deployment, especially in the US, we've kind of, most folks have the internet service, the developers, the service providers have kind of built things out, and we're kind of at a point where it's almost, not done per se, but we're not building new networks as fast as places like Bangladesh. So places here where you're actually actively deploying internet and still growing and building, I think it's very important for you to have a voice in the future of those internet protocols. So hopefully you've got a little bit of interest now in the IETF, and I'd like to talk a little bit about what they're working on and where you might be able to contribute. The three big things I think that, at least from my perspective, are important to the IETF right now are enabling the Internet of Things, which you've heard a lot about already this morning, and trying to find ways to connect, not just billions of people, but potentially, tens of billions of devices. Also strengthening the technical foundations for privacy and trust in the internet. Obviously, if you watch kind of politics around the world, there was the Snowden incident, we call it. We found out that the US government was doing a lot of spying, and we found out that other governments were doing a lot of spying. In order to protect ourselves from that, we can build more privacy and more encryption into the internet itself. And the IETF is looking at that very actively. There's also promoting real-time collaboration. Trying to ramp down work on IPv4, and are looking more at ways to migrate away from IPv4, and all new work is focusing on IPv6, including IPv6. So new protocols in the future are going to be built around IPv6, which is another good reason to deploy to your network, as well as getting involved in making sure they're running properly. Another area that I think is really interesting right now is DNS, mostly because of the DNSSEC, DNS security things that are happening. The DNS security standard itself is being built in the DNSOP, which is DNS Operations Working Group, and then DANE, which uses DNSSEC to do all kinds of other authentication, which is really neat. I can talk about that for a long time as well. There's a Dane working group that's working specifically on that. I encourage you to look into that if you're involved in security at all. There's also some neat routing stuff going on. The secure interdomain routing, which we heard about the ROAs. That's where RPKI and Apple System is developed, is in the SIDR working group. And there's also the IDR working group, which is interdomain routing, which obviously is what the internet's all about. And then finally, going back to the privacy and security issues, there's several groups working specifically on TLS. You may know it as SSL. TLS is actually the newer version of SSL. SSL was defined in 1996. All the versions since then have been called TLS. DTA, which is using TLS in your applications, is one working group that might be interesting. Dane, as I mentioned already, and then also TLS itself is a working group that defines that protocol and the core protocols there. So, if any of that is interesting at all, you want to get involved. And how you can get involved is actually fairly easy. The majority of the ITF work is conducted on mailing lists. So, not surprisingly, the Internet Engineering Task Force uses the internet to do their work. Again, as I mentioned, this datatracker.itf.org/WG has a list of all the working groups. So that whole list was kind of on the chart before. They're all listed out there. Each one of them has a charter, existing documents, and links to their mailing lists. Joining the mailing list and starting to read what's going on and comment on drafts. They're always looking for new people to review drafts, kind of read over a draft and look, even just for clerical errors. Is there bad punctuation? Is there bad spelling? That's helpful. But also, of course, if you have technical knowledge on things you deploy in the real world, they're looking for that input as well. All mailing lists are completely open. Feel free to join any of them that you want. I really highly recommend that you only join one to start with. There's a lot of interesting work going on there, and I made the mistake when I first got involved in the ITF of joining a bunch of working groups, joining a bunch of mailing lists. I was just completely overwhelmed. So I would say pick the one that's most interesting to you, join the mailing list, kind of give it some time, see how everything works, and then perhaps if you have more spare time, advance from there. There's also 3 ITF meetings every year. They move around to different locations around the world, and there is remote participation available as well. But again, as I said, most of the work actually happens on the mailing list. There's folks who have actually written complete standards without ever showing up to a meeting. So it's not required to attend meetings. I know that can be quite expensive and time consuming. They're there and they're available, but they're not required. Mailing list is where the real work happens. As far as meetings do go, we were just last in Dallas in March, and next up in July we'll be in Prague, and then following that in November in Yokohama in Japan. So those two are a little bit, not very close, but a little bit closer than where they are sometimes. You can see going from there, we have our first meeting in the Southern Hemisphere in Buenos Aires, Argentina, at the beginning of 2016, and then Berlin, and then back to Asia in Seoul. Last meeting, we had 1,200 attendees from 57 countries, and there's some links here. If you look at the slides later, you can look at kind of more information about what went on at the last meeting. The next meeting, as I mentioned, is in Prague. There's information here on that link. Meeting/93. It's going to be the 93rd meeting of the ITF. And of course, there are audio streams, web conferencing systems, and Jabber chat room is all set up for remote participation. So you can participate in that meeting remotely. If you want to go to a meeting, we have a fellows program for the Internet Society where we actually help fund a few folks each year to go to the meetings, mostly from developing countries, places like Bangladesh, where that burden of airfare and hotel costs in a big city is a lot higher. So we bring folks in, engineers like yourselves can apply and potentially get a trip paid through the ITF, and also you get a mentor for the week. You get shown around, kind of see the whole process, how the meetings work, and really get a good introduction to the ITF. We've had several fellows who have come to the ITF through the program and then became very, very active participants, even starting local communities around the ITF and then participating very, very highly. In addition to bringing engineers to the ITF, the Internet Society also has a regulator to the ITF program, where we bring ministers and other government regulators from all over the world to come see how it works. It is involved in working group meetings. They have a lot of side meetings, get to meet with people and see how it all works. Which is another, again, there's links on both these pages to those programs. You can see more and maybe possibly apply. So, help us create better standards. There's a newcomers page. There's another page we call the Tao of the ITF, which gives a lot of information, a lot of handy questions there. Like I said, right now, as far as network operators go, the IPv6 ops and DNS ops. I think are probably the two you really want to focus on. And again, you can join the mailing list, you can read drafts and provide comments, and of course, at the point where you come up with your own idea, you can submit a draft. With that, I'd be happy to take any questions, and I ran through a lot of information pretty quickly.
Hi, am I remember last year there had some code error on SSO regarding SSO came up. Do you have any strategy regarding that issue? How many servers affected worldwide?
Oh, I'm sorry, I didn't understand the question.
There was some glitch, code errors on SSO.
Is the OS stuff?
Yeah,
absolutely.
So, do you have any strategy worldwide? How many servers compromised or specific?
I don't know how many were actually compromised. I know that the bug was found pretty quickly, and was, there was actually code available fairly quickly to get it patched. I don't know.
Everybody patched.
Yeah. I'm sure there was some compromise, but I don't have any numbers now.
Thank you.
Okay, I also have one more question. What's the actual difference between IETF draft and RFC?
Sure. So IETF works on two different types of documents. Well, they work on internet drafts. So all, whether it becomes a BCP or a low standard, or even just expires, all work starts with an internet draft. And then once it's gone through all the last calls and it's actually published by the IETF, it's called an RFC. So RFCs are kind of more finished documents, and internet drafts are in progress. Thank you very much.
Thanks to Chris for a beautiful presentation on how we can get involved in IETF task forces or IETF working groups. Now we have a wonderful presentation from Mr. Bhaskar about teaching to the readability. So please welcome Mr. Bhaskar. After this is the last part of this session, and then we'll go for our lunch break. Mr. Bhaskar.
So, yeah. So, ladies and gentlemen, my name is Bhaskar Bhattacharjee. I'd like to start my presentation. I think I need this mic a little closer, isn't it? So, I can promise you, it's a money back guarantee. My presentation will be very, very poor. You will not enjoy it. So, ladies and gentlemen, I have two challenges. One, I can't make eye contact with you. Another, all of us are hungry. So it's a big challenge. So hopefully I will try my best to overcome both of the challenges, as I have overcome challenges in my life. Again, come to your questions. Many of you have questions in your mind. In a highly technical conference, why this person, this visually impaired person, blind person came here? Why he need to talk? I will try to answer these questions through my presentation. Okay? You can see, you are seeing a icon. I told you that my presentation will be not interesting. Already this icon you are seeing the spelling mistake. So I started with the mistake. Again I come to the point. You can see why I am here. Because in the world there is a 1 billion people with disabilities. So whatever development you are making, including infrastructure or informational, that should be accessible to these 1 million people with disabilities in the world. That's why I'm here. We are not finding a single website in Bangladesh, service websites, which are accessible to the people with disabilities. We are not finding a single telephone companies or the corporates who are serving needs of accessibility for people with disabilities. That's why I'm here. You just seeing this data. WHO are saying that globally we have 15% people who are people with disabilities. In Bangladesh, government have three types of data. In fact, one, there is a hard soul survey. They are saying almost 10%, 9.6% is the people with disabilities. Another statistics by the Bureau of Statistics, they are saying that it is almost 10.5% is the people with disabilities. Another interesting data is we are getting by the government with the Ministry of Social Welfare. They are saying people with disabilities are not more than 1.4%, which is really fine. So that is there is again we are seeing that there is a huge gap in the data, but there is not less than 10% people are people with disabilities. You will be surprised to know that still you have almost 50% people who are low literate. So the service provider who are here, if you consider me, then you can cover the 50% people who are low literate. So whenever you are developing any service, any internet-based service, e-service, or any telephonic things, or any other informational things, then you must consider these 50% people of this country. Same things globally, same questions are relevant globally. As I told you, we have 1 million people with disabilities. So, why we will consider that? In this century, for the first time, we have the Human Rights Treaty in this new century, that is the Rights UN Convention on Rights of Persons with Disabilities. In this convention, there is two separate articles. One is Article 9, which ensures accessibility for people with disabilities. Another is the Article 21, that is right to information. Ladies and gentlemen, Bangladesh and other large number of countries has signed and ratified this convention. That's why you are legally bound to ensure all the service should be accessible for the people with disabilities. We can easily, people with disabilities can easily go to the court, or we can report to the UN system that the companies, corporates, and governments are reluctant to ensure the rights of persons with disabilities during the providing of service in accessible format, such as the telephone companies. They are reluctant. Like if I would like to check my balance of how much money I have in my phone, then I can't do it. I am not able to browse their websites. as this is not accessible. We are not able to communicate as there is no voice SMS. We are not able to communicate. There is not enough text-based facilities for the communications. That's why we need to consider the accessibility needs of persons with disabilities. In Bangladesh, we are seeing there is 3 types of education system for the people with disabilities, especially students with disabilities. One is a special schools, which I have studied, that there is a school for the blind and these types of things. There is inclusive educations, which are not very effective, but government are spending huge amount of money by the name of inclusive educations. Another is an integrated education. That means there is some hostels where people with disabilities can stay, and they are going to the normal school to study. Remember, we are saying only 4% children with disabilities are able to go to the schools in Bangladesh. So this is really sad thing, sad part of the things, but still we are progressing. Nowadays, ICT skills is one of the vital things. You are seeing I'm here because of my ICT skills. We are training, providing training to the youth with disabilities who are learning computers. Even they are using a smartphone. You are seeing my smartphone here. I am using a smartphone, and many blind people are using a smartphone with the text-to-speech and other technologies. So it is very much possible, and they are becoming a human resource. Government have initiated that is to make the 24,000 websites, which is called National Web Portal. They are trying to make it accessible. We are trying to make it in W3C compliant. We already have a Bangla text-to-speech, even though that quality is not that up to the marks. I will show you how it look like. And we have developing the screen reading software, which are also the open source. Anybody can download. It's the NVDA. You can download from the internet. And we have the eSpeak text-to-speech. That is also open source, so it is free. Anybody can access that. The mobile phone, I already told you that. Even though mobile phone company services are not accessible for us, but we are developing the software by which people with disabilities can access mobile phone. Just such as talkbacks, we are using eSpeak text-to-speech for accessing Android phone, etc. I already told you that web accessibility, maximum web accessibility. What do you mean by the web accessibility? That means that any websites we people with disabilities can access, navigate, receive information without any barriers through my adaptive technology. How I am using the computer by using audio input or braille display or the low vision people, they require the things, and we need to avoid the scan files such as JPG, which are not accessible. So that is one big things we need to do. We need the national web accessibility standard. We need a policy for that. And if we have a policy, then I think other companies and service providers will follow that policy. I already told you there is lots of tools and applications that exist in Bangladesh, such as we have the digital braille. We are making Bangla braille. We have text-to-speech already, even though that is not up to the marks. There is a challenges like banking facilities are not accessible, ATMs are not accessible, and we need to work on that. And we are promoting the open source software. As you know that people with disabilities, the poorest of the poor in the country. Not only in Bangladesh, even in US also we find that people with disabilities is the poorest part of the country. And even we saw in Japan's in developed countries, and definitely in developing countries, we are the poorest of the poor. You know that there is an access to information program of Prime Minister Office. They have lots of activities to ensure that accessibility needs of people with disabilities in Bangladesh. So they are facilitating the whole issues. We have done a wonderful work. That is, we have produced all the textbooks plus grade 1 to grade 4 in accessible format. That means we have converted these books into the Unicode. We have just converted this book to the accessibility book, and also we have converted these books to the multimedia books. I will show you what's called multimedia books, and also we have produced make the books in digital grade, and all are available through National Content Repository, which is www.infocus.gov.be. You can find all the textbooks on the National Content Repository. So anybody can download and listen these books, print the books in Braille. So it is a unique example for the world that how you can make it inclusive publications. The books which you can see, that books I can listen. The books which you can see, read by seeing, I can read by touching. So that is the inclusion, and that is the universal design. We have just made this with the collaboration of Prime Minister Office. Inclusive publishing, we are working with the publishers, especially how to make inclusive publishing. We are just promoting the EPUB 3. So if they make these books in EPUB 3, then it is easily possible to make books in accessible format. What we are meaning about the accessible book? Accessible books means the books which we can read without any barrier. Not only books, we are talking about the content also. Whatever content which can be read and understand without any barrier by the people with disabilities. That is accessible books, and including websites, contents, whatever. I'm here because of the ISEF Asia. They have, I think they have nominated me to come here, and we have received the ISEF Asia award because of our work. We are thanks to the organizer for inviting me here, and we're seeing another great things. Last month we have received the International Excellence Award from London Book Fair. You know that London Book Fair is one of the biggest book fair in the world. And myself was there to receive the award for the inclusive publications. They are saying that excellence award for inclusive publications. I told you that we have started to distribute the smartphone. We have handed over 35 smartphones to the youth with disabilities. They are accessing them. So anyone here, you can come forward to work with us to promote these types of technology in Bangladesh. Thank you, but not thank you fully, because I would like to show you some of the products, and then I will complete my presentation as you are hungry now. So I'm going to show you one book at least. Ladies and gentlemen, I am listening the computer and I am giving the presentation. So this is the technology. This is the primary level books. I would like to go for a English book first because there is some foreign here. You will see these books and this at the same time. I'm sorry there is no sound system. Maybe you cannot listen that. Sorry. Maybe some technical problem again. I'm just coming another book. Or because of some technical reason, I'm showing another books. Maybe that will be work. Another software that is AMIS, Adaptive Multimedia Information System. You are seeing now the books. You are seeing the book, isn't it? In the multimedia, I think you are seeing the text, and I'm listening the books. Ladies and gentlemen, my daughter, she is almost 7 years old. Every day she came to me, Papa, I think it's not coming. So it's not coming. Okay, whatever. You just understand there is audio also. This is the inclusive design. People can listen these books, can read these books, and at the same time we can print the braille. Lastly, I'd like to show one English book if there is one. You can see this is one book I'm showing that we made for the user guides. This is English. So this is like, you can see this is the books, like people can see, same time listen. And this is the, we are talking about the accessibility for these types of books. So lastly, I'd like to say two things. One, if God, just last night I had a dream, God came to me and they're saying, Ashkar, I will give you the highlight, but there's a condition. I will take up your laptop. So I say to God, my dear God, I don't want to see. I need this device because this is the knowledge. Lastly, 6 months ago also, I was not able to teach my daughter. Always she came to me with her printed books and said, Papa, please teach for me. I said, no, your Papa can't see. Now I can teach my daughter because I have the books which can listen by me and read by my daughter. That is that. Thank you. If you have any questions. So if you have any questions or other questions.
Okay, seems like no one has any questions.
Okay. Thank you very much. Hopefully you'll enjoy my presentation. Thank you.
This was the last station, last part of our station 2. So we can go for our lunch, which has been waiting for a long time. I will request you to go to the ground floor where our other volunteers will take you to the dining and take only a half an hour break, and I'll request you to come back as soon as possible, please, because we have some more interesting presentations waiting for us.
মানে এখন কি ব্রডকাস্ট কি আছে না ব্রডকাস্ট কি মানে রেকর্ড হচ্ছে
হ্যাঁ রেকর্ড হচ্ছে
রেকর্ড করে লাভ নাই তো
আবার ইউআরএল চেঞ্জ হয়ে যাবে ইউআরএল তো ঠিক থাকে না
না কিন্তু না এটা বন্ধ করো না 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 শুধু শুধু ইয়া রাখবে এই অপো
বন্ধ করে দেবো না চলবে বন্ধ করে দেবো